Okay, welcome back everybody. Here we go, lesson number 2. I decided that every day I'm gonna bring a guest. Today, here's our guest. This is the purple duck that Roman gave me for Christmas. So thanks, Roman. Your purple duck is now our guest. All right, he's gonna sit right there. Hopefully you either have a piece of paper and a pencil, or you've printed out the notes. It doesn't matter if you have the printout piece of paper, works fine. Just as long as you're following along and writing your notes. Okay, so lesson number 2. First thing is we're gonna review what we talked about for lesson number 1. We talked about the distance between 2 diagonal points. So write that down right here. The distance between 2 diagonal points. All right, hopefully you did your homework and you've got it all figured out. So here's an example. So here's a right triangle with 2 legs and a hypotenuse. We're going to count the distance of the legs. This right here says find AB. That means they want us to find the distance of the leg AB. So we're just going to count it. 1, 2, 3, 4. That one's 4. This right here, find the distance BC. So we're just going to count it. 1, 2, 3, 4, 5. Okay, find the distance AC. AC is the diagonal line, or our hypotenuse, so this is where we're going to use the Pythagorean theorem. So if you remember from yesterday, we did C equals the square root of leg squared plus leg squared. Well, we've already figured out the 2 legs, which I forgot to write down. Okay, so here we go. C is the hypotenuse, is the square root of 5 squared plus 4 squared. Put that in your calculator. Hopefully you've all found a calculator that you can use. Square root of 5 squared plus 4 squared equals 6.4. Remember, we're rounding to the nearest tenth. So there we go, 6.4. The length of that diagonal side, 6.4. All right, so here's something I want us to think about. Describe a way to find the distance between 2 points on a number line without counting the spaces. Because counting can be too slow when you're talking about big numbers. So let's say you've got a number line. You've got a point here at 12. You've got a point here at 83. And somebody asks you to find out how far apart those 2 numbers are. Well, you're not going to sit there and count all the way till you get to 83. That would be too slow. Instead, you're just going to subtract. So you're going to take the big number, 83, minus the small number, 12, and that equals 71. So now you know this point and that point are 71 spaces apart. Okay, it works the same with negative numbers. Let's say you have a negative 36 here and a negative 5 here, and somebody asks you to find out how far apart those 2 are. You're just going to take the big number, which in this case is the negative 5, the bigger number, subtract the smaller number. So you're going to go negative 5 minus a negative 36 equals, now remember, those 2 negatives make a positive. So it's really negative 5 plus 36. 2 negatives make a positive. So they are 31 spaces apart. So you're not always just going to be counting. Sometimes you're going to have to do math to figure out how far apart they are. Okay, so lesson number 2. Here we go. Essential question for lesson number 2. Write this down. How do I find the distance between 2 points? How do I find the distance between 2 points? That's exactly what we did in lesson 1. We found the distance between 2 points. And we used the Pythagorean theorem. That's how we did it in lesson 1. But lesson 2, we're going to elevate it just a bit, and we're actually calling it the distance formula. So to answer our essential question, we're going to say we're going to use the distance formula. But here's the thing. The distance formula and the Pythagorean theorem are exactly the same formula. They're exactly the same thing. They're just written differently sometimes. So let's compare them. So Pythagorean theorem written like this. Hypotenuse equals square root of leg squared plus leg squared. Okay. If you were to Google the distance formula, this is what you're going to find. D equals the square root, parentheses, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's what you're going to find if you Google the distance formula. So you can't tell it by looking at those, but those are the exact same formulas. This part right here is just asking you to find out how long the horizontal leg is. So that's the horizontal leg. Because it's on the x-axis, it's going left to right. And this right here is just asking you to find out how long the vertical leg is. So that's the other leg, because the y's are the vertical part. So it's exactly the same thing. This just adds a piece of confusion that you might not need. All right, so let's work on this. So go to your next page. You're gonna have a graph something like this. They want us to find the distance BC, which is right here, the distance AC, which is right there, and the distance AB, which is a diagonal line. And if you'll notice, this forms a right triangle. So we can use our Pythagorean theorem, aka distance formula. So we have coordinates here. This is 1, 2, 3, 4. So find, and then going up this way, up to 8. All right. So find the distance between B and C. Well, B starts at 8, and C starts at 4. 8 minus 4 is 4. They're 4 apart, so that equals 4. Okay, find distance AC. Well, A starts at 2 because we're going horizontal right now. Let's see, let me put a 4 right there. A to C is horizontal, goes from 2 to 4, and that distance is 2. So, finding the distance A to B, we're just going to use our Pythagorean theorem, aka distance formula. So you're going to go, the distance equals the horizontal leg, 2 squared, plus the vertical leg, 4 squared, and stick that in your calculator. 2 squared plus 4 squared. 4.47. The 7 tells us to round up because we're rounding to the nearest tenth. So 4.5. Now, it doesn't matter if you put the horizontal leg first or the vertical leg first. It doesn't matter because addition has the commutative property. So if you had stuck it in your calculator like this, if you'd have gone, I'm going to put the vertical leg first and then the horizontal leg, it's perfectly fine. You're going to come up with exactly the same answer. All right, so let's look at this one. Here we have a diagram. I'm not really going to call it a graph because there's no markings. So we're actually not going to be able to count this one out because there's no markings on it. But we do have the coordinates where the endpoints are. So go ahead and make that into a right triangle. This coordinate is a 2 and a 2. So it's over 2 and up to 2, over 2 and up 2. This coordinate right here is a 6 and a 4, so over 6, up 4. So we're just going to figure out how long is the horizontal leg. And if you go from 2 to 6, you're moving 4 spaces. But if you want to use the whole subtraction method, you can do this. 6 minus 2. 6 minus 2 equals 4. So that horizontal leg is a 4. Now we're going to figure out our vertical leg here. Oh, I forgot to draw my right triangle. Our vertical leg starts at 2 and goes up to 4. So they're 2 apart. But if you're using the subtraction method, you would say 4 minus 2 is a 2. Then you're just going to stick it in your distance formula, aka Pythagorean theorem, because we're looking for that hypotenuse. So you're going to say the distance is the square root of leg, which is a 4 squared, plus the other leg, which is a 2 squared, and that equals, and I just realized looking right above, that's the exact same one that I just wrote right there. So it's the exact same. I'm not even going to put it in my calculator. I know it's going to be 4.5. Okay, here's another one. Find the distance A to B. So A has coordinates of 2 and 1, so it's over 2 up 1. B has coordinates 5 and 16. So it's over 5 up 16. I'm gonna make a right triangle out of that. Okay, let's find the horizontal leg first. This one right here. 5 minus 2 tells me they're 3. So this leg has a measurement of 3. And we're going to find our vertical leg. The bigger number is 16. So we're going to do 16 minus the 1 is 15. So that leg is a 15. Now, because we're looking for this diagonal one, we're going to put it in our distance formula. So distance equals square root of leg, so 3 squared, plus the other leg, 15 squared. Distance equals square root 3 squared plus 15 squared, 15.29. So the 9's going to have us round up. So 15.3. And here's another thing to remember. Your your hypotenuse, your vertical side, is always going to be the longest. If you come up with a smaller number than your legs, then you know you probably did something wrong. So these are turning out good. Okay, so let's say we do not even have a graph to look at. We just have the points. Well, it's okay. We can do it. Because remember, when you have your coordinates, the x coordinates first, then the y. The x coordinate first, and then the y. So we're just trying to figure out how far apart these two numbers are, these two x coordinates are, because that will be our x leg, or our horizontal leg. So I'm going to do my biggest number, 2 minus a -1. Two negatives make a positive, so this is really 2 plus 1. Oh, whoops. 2 plus 1 equals 3. Okay, so my first leg is a 3. Now, let's find our other leg, our vertical leg. These are our y coordinates. You take the bigger number minus the smaller number. So 2 minus a -4. There are two negatives make a positive, so that's really 2 plus 4 equals 6. So now we have a leg that's a 3 and a leg that's a 6. Go ahead and put it in the formula. Distance equals square root 3 squared plus 6 squared equals 3 squared plus 6 squared, 6.7. Okay. It's actually sometimes easier not to have a graph and just use the numbers. All right, so let's look at this one. We have our x and our y, our x and our y. We're going to do our x leg first, or our horizontal leg. We've got a 4 and a 3. You're going to take the big number minus the smaller number. So 4 minus a -3. Two negatives make a positive. So 4 plus 3 equals 7. So our horizontal leg is a 7. Our vertical leg is, we have a 3 and a 4. So I'm going to do 4 minus 3 equals a 1. So our vertical leg is a 1. Now remember, if you're doing this and if you accidentally went 3 minus 4, so I'm going to write it down. What if you accidentally went 3 minus 4 and you got a -1? Just remember that distances are always positive. We don't have a negative distance. So you're just going to drop the negative and say, oh, it's really just a 1. Okay, stick that in your distance formula. Distance equals square root of 7 squared plus 1 squared. Those are our legs. Uh, 7 squared plus 1 squared is 7.07, so we're going to round up to 7.1. And yeah, kind of ran out of room there. 7.1. Okay, one more to go. X and Y, X and Y. We're going to find our X leg first. So I'm going to do 2 minus 0 is equal to 2. That's our horizontal leg. And I have a 4 and a 3. So I'm going to do the biggest one first. 4 minus 3 equals 1. So my vertical leg is a 1. So now the distance between those 2 points, if I were to graph them, is 2 squared plus 1 squared. Those are my 2 legs. Square root 2 squared plus 1 squared equals 2.2. Okay, so that's the end of this lesson, distance formula. If you go to schoology.washk12.org, you're going to be able to find the homework assignment. It's called number 2, distance formula. And if you want full credit, have it in by April 1st at 3 o'clock. And then it's not due, if you want late credit, it's really not due till midterm, which is on April 17th. Okay, everybody take care of yourselves. Oh, sorry, there's the duck. See, he's still here. Okay, see you next time. Bye.